let's look at a projectile question where something goes straight off a cliff, 14 meters high, 20 meters per second, and comes down to the ground. So being shot at 0 degrees. Now, the first thing that might kick in be handy to find the time. Now, the nice thing is the amount of time it takes to do the actual path of the curved path of the projectile and the time it takes to drop straight down would be the same. Since gravity is the same for both and that dictates how long it would take, it works out really, really nice. So since we have the height, we can easily calculate the time it would take for something to drop straight down 14 meters. Now, the little expression would work nice is the height is equal to 1/2 gt squared. And if we rearrange for time, that would be 2h divided by g square root. Put in 14 meters for the time and 9.81 for gravity, and we get a time of approximately 1.7 seconds to go the projectile route or just drop straight down. It wouldn't make any difference. Now that we have that, this would actually be our time of flight. We could use this to find out how fast it goes in the vertical direction. We could use that to find our change in speed in the y direction, which would be gravity times that 1.7 seconds. So we multiply those two together and we can find out we get a Vy of 16.6 meters per second. So when it hits the ground, it's going to keep the exact same Vx that it had before. There's no speeding up or slowing down in the horizontal direction. So the Vx will stay the same at 20 meters per second, but now it's gained 16.6 in the horizontal or vertical direction, which results in it hitting at an angle. So we can use our trig and Pythagoras to figure out how fast it's going in the angle. So if we use basic Pythagoras, we find that it is 26 meters per second, and then using basic trigonometry, we can find the angle right here, and it would be hitting at approximately -40 degrees. Now, we can also calculate the range of the projectile, which is basically dTV. We'll use the time of flight that we found before, as well as using our Vx. Since it's a horizontal motion, the range goes sideways. We only want to use the speed that is going sideways, which would be Vx. So using our time of flight of 1.7 seconds and our speed of 20 meters per second, we can multiply the two and we get a range of approximately 34 meters. So we've got the time, we've got the final velocity, and we've got the range, which would be all the things you would usually find in a question like this.